Good afternoon. Can you sound okay? All right. I was really hoping not this many people showed up. This is probably not the sexiest talk, and to have it right after lunch. We've had to strategically place employees in the audience to smack people that fall asleep. So, I'm Jeffrey Ricker, co-founder of Ricker Lyman Robotic, and we have offices here in Kiev, Lviv, New York, and beautiful, exotic Iowa. And I'm here to talk about data governance, big data governance. And here's the scope of what we're going to cover, right? We're going to say, what is data governance? Why does it even exist? Why is it a thing? Why is it critical to big data projects in large enterprises? Then we'll go into talk about the tools that are available for managing data governance, how to implement data governance, and touch briefly on the future. Now, we're not going to be able to dive very deep into this in an hour. If you've ever pulled a book on data governance, it looks more like an old phone book from the 1980s. It can be quite weighty. But we'll try to give you the high level and hopefully arm you to go dive deeper into it on your own. So what is data governance? Here's the definition that we use. It is the orchestration of people, processes, technology, and policies to ensure the availability, usability. Paul, stop when they're leaving. It's a boring definition, but let's break it down, all right? It's the orchestration of people, processes, technology, and policies. Not a lot of technology there, right? It's more about people there, and people things. And to ensure data has availability, usability, integrity, consistency, auditability, and security. That's a lot of ground to cover. But why do we have it? For these objectives, right? And these will start to make sense when you're talking about big data and data lakes and data processing and running an enterprise on this stuff. Understand the implications of a data outage. Understand the impact of a data change. Migrate the corruption of data over time. Mitigate. Make it as small as possible. It's going to happen. You want to try to mitigate it. Mitigate the impact of data outages and rapidly identify and fix data impacts to prevent them from reoccurring. So if you have implemented data governance properly, these are the outcomes that you get. So why is it even a thing? I mean, why so much people involvement with something that is really just moving bits and bytes over wire and into databases? Well, to get into that, we have to talk about how human information technology really is. And first off, I want to give you a definition of information, which is that, and we call this Locke's Law, that the communication is the transfer of one thought from one human's mind to another human's mind. And you only can do that through a physical medium. And information is the physical form that that thought takes. So information is inherently human. We're not talking about data, we're talking about information, right? So transferring one thought from one mind to another has to go through a physical realm, and that is information. So what it means is, it's not like what we're usually taught with a data pyramid, which says that data adds up to information, information adds up to knowledge, and knowledge adds up to wisdom. I believe this silly diagram single-handedly causes more information overload or data overload on enterprises more than anything. Because what it says visually is, oh, if I get a lot of data, the more data I have, the more knowledge I have. And then the more information I have. The more information I have, the more knowledge I have. So let's get as much data as we can. It doesn't work that way. So starting with the concept that information is inherently human-centric. Then we go to this other concept, Shannon's Law, which says that the fundamental problem of communication is reproducing at one point either exactly or approximately the message that oriented on the other point. Claude Shannon. Brilliant guy. So he gave this model, right? So you have this information source that goes through a transmitter. It goes through some medium, which will always have some degree of noise to it. And it ends at a receiver with another destination, right? So this is kind of the basic model of information extending Locke's law. And the semantic aspects of communication are irrelevant to the engineering problem, right? So we end up with coding, encoding. What Shannon was talking about is there's only a finite number of things that you need to transmit, so you can create codes for those things and you can get much, much higher fidelity. Hence the development of Morse code. He explained how that worked. And it also explains how when we're dealing with data, we're always finding these encodings. We're always giving identifiers to employees and identifiers to customers and identifiers to locations. But there's a corollary to Shannon's law, which is Wittgenstein's law. And what Wittgenstein teaches is that no human can perfectly express a thought physically, and no human can perfectly receive that information. There will always be some impedance, both in the creation of the thought as information and the receiving, the transformation of information back into thought. So semantic incongruity is unavoidable. So there is in these models the semantic gap. And by semantics, I mean what the words actually mean, right? So yes, I've expressed a code for an employee, but what do I mean by employee, right? And the semantics of this and the encoding of this gets very complicated very fast. Now here's a data point that we've pointed at for years, which is to be fluent in a language, basically fluent in any language, you need to know about 10,000 words. Well, it just so happens there are also 10,000 encoding identifiers in EDIX12 and EDI-EDIFACT. Both of them have 10,000 words. That's the standard that's used between companies to ship invoices and purchase orders and advanced ship notices and rails and all the business-to-business commerce communication. Is to communicate all that business requires the equivalent of a language, a human language, in just identifiers. So here's a perfect example that we've come across. Let's say you're integrating all the salary across an international database, an international company. So in the US database, you have a table called salary, right? And you're like, oh, that's the salaries, right? And the numbers are in there. You can assume that they're US dollars. Over in the French department, you have a table called salary. Oh, it translates pretty well, and it's in euros. Easy enough. Except the US definition of salary, the semantic meaning of salary, is different than the semantic meaning of salary in France. Right? In the United States, we give salaries as gross salary before taxes. So that would be what was in the database. Whereas in the database in France, they're listing the net salary after taxes plus a lunch allowance. So at the face value, you're looking at integrating two different databases. They look exactly the same, but they are actually semantically different. Now compound that over and over and over and over again, right? From across applications, to across divisions, to across companies, to across industry. These semantic differences compound themselves. And there's just one more joy, Miller's Law. So Miller talks about another problem with information technology, which is the inherent limitations of human cognition, right? We cannot just absorb an infinite amount of data. We have a very physical limitation to the amount of data that we can bring in. He wrote a paper called The Magic Number 7 plus or minus 2. And what he identified was that on any given sensory input, humans can only differentiate between 5 to 9 distinct things. Like you can have you can distinguish 9 different shades of gray, or 9 different decibel levels, et cetera, et cetera. So we have a bottleneck in how much we take in information. So you have semantic gaps and bottlenecks with humans with information. And that is why we have a data governance problem. And what this cognitive limitation, what Miller's law manifests itself is with aggregations. Now you've probably seen this, balance sheet, right? It is a way for a corporation to look at all of its assets and liabilities. It's a financial picture of a company, of an enterprise as a snapshot. But it's all aggregation. And the reason it's aggregated is because no human could possibly take in all the details, right? There's no way for a human mind to process every single item the way a computer can. It has to be aggregated for the human because of Miller's law. So to do that, humans are always creating hierarchies of information, right? The balance sheet is nothing but a taxonomy for financial information within a company. You probably came across taxonomies in biology class where you start with the kingdom and then you go to class and then you go to family and genus and finally get to a species. It's a way for us to organize all the animals in the world. We couldn't just look at all the animals in the world. We need a taxonomy in order to get our mind around it, to group it. Taxonomies show up again and again and again in the enterprise. I mean, just think of how when you go to a grocery store or a hardware store, how the aisles are lined up and products are grouped together. That's a taxonomy that you're using to navigate through a grocery store. So taxonomies, if there was one taxonomy, that would be great. But within any company, there are multiple taxonomies. Perfect example, how do we look at sales data, right? You would think that within one company, there would be one view of sales data, but there's not. The sales department wants to look at sales data aggregated by sales region because they want to know which salesman within the company is doing what. And they usually divide their sales regions geographically, right? But logistics doesn't care about the sales regions. They're worried about distribution centers. They want to know what products are moving through what distribution centers. Completely different geographical layout, different geographical aggregation of the exact same data, a different taxonomy. Again, marketing is interested in it from the statistical areas that they get demographic information from. And accounting wants to probably look at it through channel partners and see who they owe money to. So why is data governance a thing? Well, different encodings, different semantic incongruities, different taxonomies. In essence, by the very human nature of information itself, causes chaos within our data. Regardless of how well you engineer your systems, no matter how much uptime you have on your databases, no matter how perfectly you transmit over the wire those signals, you're going to have problems with your data because information, by its very nature, is human-centric.